Hello everyone, welcome back to JM Lectures. JM stands for Just Mary, that would be me. And today we are on the final video of the grade physics, grade 12 Matric questions. We are on the last unit, unit 8, atomic physics. So without further ado, let's move on to the question. Question number 29. Which of the following has an electron volt unit? Choice A, charge. Choice B, potential difference. Choice C, energy. Or choice D, electromagnetic intensity. So let's go into a bit of what it means by an electron volt. So an electron volt is actually an easy thing to remember when you break down the name. An electron volt can be calculated by seeing an electron with a charge of 1.6 times 10 to the power of minus 19 coulombs moving through a voltage of 1 volt. So an electron volt is simply the energy from when a charged electron moves through 1 volt. So I basically just gave you the answer. It's energy. It can be calculated because energy is equal to the charge multiplied by the voltage. In this case, the charge, 1.6 times 10 to the power of minus 19 coulomb, is multiplied by the voltage, which is simply 1 volt. So we get that the energy is given as 1.6 times 10 to the power of minus 19 joule. And that is simply 1 electron volt. So instead of saying 1.6 times 10 to the power of minus 19 joule, which is a bit long, you can simply represent this as 1 electron volt. So electron volt is a way of representing energy. That would be choice C. If we look at the other choices, we see that choice A says charge, and the unit for charge, actually mentioned earlier, is C, or coulomb. For choice B, we have a potential difference. Potential difference can be noted by PD, and PD is represented by V, which is voltage. We have choice C, which is our correct answer, energy, and normally energy is represented by J, or joule. But again, since energy is neither created nor destroyed, it just converts into different forms, you usually have different ways of representing energy. There's potential energy, kinetic energy, heat energy. In this case, an electron volt is the energy of an electron moving through 1 volt. So we have joule, and we also have electron volt. The last choice, choice D, electromagnetic intensity, is measured by an interesting unit known as watt over meter squared. So watt over meter squared is how you represent electromagnetic intensity. But again, our correct answer is choice C. And that's it. Moving on to the next question on atomic physics. Question number 30, the last question of this Physics Matric playlist. In Rutherford's experiment, a beam of positively charged alpha particles was projected into a thin piece of gold foil. One of the observations of this experiment is that some charged particles deflected through a large angle, 10 to 90 degrees, are those concentrated in one place. What conclusion can be drawn from this observation? So before getting into the choices, let's just talk about what this experiment is. So Rutherford's experiment, or Rutherford, was one of the scientists who tried to figure out what an atom looks like, or tried to define the atomic model. So I have a playlist describing all the atomic models from Thomson to the quantum mechanical model. I strongly recommend you look at that video to have a greater understanding of how the atomic model we have now came into existence. So in Rutherford's experiment, let's try to demonstrate this graphically. He had a gold foil, and let's try to represent this gold foil like so. So this gold foil is extremely thin, and what he did is he shot a bunch of positive alpha particles onto this gold foil. So we have alpha plus. It's very important that you know that these particles are positively charged. So he saw different things that he did not expect. He expected all of the alpha particles to simply flow through, but instead he saw 3 main observations. His first observation is that the majority actually did come through. A majority of them did actually go right through the golden foil. Then he saw that some others were deflected. at a large angle. So they would come and then they would deflect off large angles. They would come in and they would deflect off large angles like so. Then he observed that yet another set of alpha particles would go to the golden foil and in fact bounce right back off. So it would go to the foil and bounce right back off. So these are the three main observations he saw. And he had three conclusions with these observations. So his first conclusion had to do with those alpha particles, the most of those alpha particles that went right through the gold foil. So his first conclusion was that most of the atom is in fact empty space. So most of the atom is empty space. That's why most of the alpha particles could flow right through. The second thing he concluded is for those alpha particles that deflected off a large angle. So for these alpha particles, he said that the positive charges of the atom are concentrated at that one place. That one place where these alpha particles were bouncing off or being deflected off, that is the place where the positive charges are. Well, how do you know that? Simple. Alpha particles are positive. So the only way that they'd be deflected off that one place, if that place is where the positive charges lie. And for his third conclusion, he concluded that there was a small central nucleus with most of the mass. So he said that this place where the alpha particles were bouncing right back off, where it's a very small place, but it's where all of the mass or most of the mass of the atom is found. So he made these three conclusions, and that allowed him to model the atom like so, with all of the positive charges found in the center, and all of these positive charges are where most of the mass of the atom lies. So let's look at the choices. We have choice A, most of the atom is empty space. That's true. That is correct. That is actually his first conclusion. But that is not the reason why the alpha particles were deflected at a large angle. Let's look at the second choice. All the atom's positive charge is in that one place. That is in fact the correct choice. So choice B, all the atom's positive charge is in that one place. Which one place? Well, that one place where the alpha particles were deflected at a large angle. That means our second conclusion. The second conclusion that we have right here, there's this one place somewhere inside the foil where alpha particles were just being deflected by large angles. And that one place is where the atom's positive charges lie. So that is the second conclusion, and that is the reason why those charges were deflected. If you look at choice C, most of the mass and all the positive charge is in a tiny central nucleus. That is true. That is true, but that was his third conclusion. That was in fact his third conclusion. So his third conclusion had to do with those alpha particles that bounced right back off with a very small angle of deflection. The fourth choice says that all atoms' negative charge is in that one place. No. It's not the negative charges, it's the positive charges. It's not mentioned in this experiment, but he said that the negative charges actually are on the outside of the atom, rotating around it. That was one of his conclusions, but that wasn't from this experiment. So that leaves choice B to be the correct answer. That is it. I really do hope you enjoyed this playlist. I hope that you've been taking the time to do the questions with me before I reveal the answer. This will really help you get good practice for Matric. So please go back and do the questions again for the sake of revision. If you did find these helpful, share it with friends. Thank you for staying with me throughout all this. And that's it.